This is the reading of Rocks and Minerals, book written by Chris Hirschman. Rocks and Minerals. Chapter 1. What are minerals? Our solar system was once a giant cloud of dust. The dust pieces were made of hard, non-living materials called minerals. Over time, these minerals began to stick together to form Earth and all the other planets. There are about 3,500 known types of minerals. A mineral is made of specific elements arranged in a certain way. The elements and the arrangements are always the same. This means that each mineral has features that never change. So those are our criteria. Solid, inorganic, same arrangement of elements and crystals arrangement, and then it's also a naturally occurring thing. Here are some of the properties. People can identify minerals by looking at each feature. A mineral's color is the first clue to its identity. Malachite, for example, is always green and sulfur is always yellow. Minerals may also be black, white, red, or almost any other color you imagine. Streak is another clue. Streak is the color a mineral leaves when you rub it against a white tile. Different minerals leave different streaks. Regular, for example, leaves an orange-red streak. Pyrite, which is fake gold, leaves a greenish-black streak. So we did both of those in class. We also did hardness, which is also important. Some minerals, like talc, are so soft you can scratch it with your fingernail. That's why it's ranked number 1. And other minerals, like diamonds, are so hard that they cannot be scratched by a steel file. And we know that 7, 8, 9, and 10 cannot be scratched with a streak plate. There's the mole scale. Minerals can also be identified by their crystal structure. Some crystals, like pyrite and garnet, are perfectly square in structure. Other crystals are long and thin with pointy tips. Some crystals look rectangular, and even some that look hexagonal, which means it has 6 equal sides. Here's a new property for us. All crystals have something called a habit. Habit is the way groups of crystals grow together. So this is how each crystal grows, crystal structure. Habit is the way they grew in groups. So what do the groups look like? The crystals of some minerals, like hematite, grow in round clumps like this. Scientists say that hematite has a globular habit. Here is other crystals that grow in bunches of needles, like here. Piles of cubes, like here, and salt there. And or rocky sheets stuck together. And I also showed you these roses the other day when I read the AR book. Habit can make crystals easy to identify, if it's one of those. Some crystals are very common and others are very rare. Quartz and calcite, you worked with both of those, are 2 crystals that can be found just about anywhere on Earth. Diamonds, emeralds, and some other crystals are very hard to find. Rare crystals are called gemstones. Gemstones can be very valuable. One diamond, called the Millennium Star, is worth at least $100 million. This big diamond is 2 inches long, but even small diamonds can cost thousands of dollars. Gemstones come in many different colors. The best diamonds are perfectly clear, with no color at all. But sapphires are blue, rubies are a rich red, gemstones may also be green, yellow, orange, and many other pretty colors. And then we got metallic minerals here that are in precious metals. So chapter 2 is how do rocks form. Rocks are made of minerals mixed together. A rock may contain just a couple of minerals, or it may contain many different types. There are 3 different families, classifications: igneous, sedimentary, or metamorphic. All rocks fall into one of these families. A rock's family name tells us about how the rock is formed. So that's how they get put into the group or family they are put into. Here's igneous. Igneous rocks form when a hot liquid deep in the earth called magma cools and gets hardened. So it's magma until it gets hard. Magma sometimes moves toward the surface through cracks in the crust. The magma hardens into rock if it reaches a place where the temperature is cold enough, so out of the core, more than likely into part of the mantle. Igneous rocks that form inside the crust are called intrusive. Inside are called intrusive igneous rocks. Pegmatite and other types of granite are common intrusive rock. Obsidian and pumice, these up here, form when the volcano erupts. Obsidian is that jet black, smooth like glass. Pumice is gray and full of holes, and it floats in water. Sometimes magma reaches the Earth's surface through volcanoes or other holes. Then it is called lava. Lava cools very quickly after it comes into contact with air or water. It hardens into rock. So both types have to harden to be called rocks. Rocks formed in this way are called extrusive igneous rocks. They've exited the earth. Basalt is the most common extrusive rock. So this is basalt. So all of those are igneous because they form when magma or lava cools, either inside or outside the earth. Here is sedimentary rock, another class or form. Sedimentary rocks form when many small particles stick together. The particles might be rock or mineral chips, little pieces. They could be little bits of plants or animals. Particles can be very fine, which means very small, such as sandstone. They can also be big, as in conglomerates. Limestone, which we have a lot of in Paulding County in our quarries, is made of stuck together shells and bones of dead sea creatures. These shells and bones fell to the ocean floor over many years ago, eventually got pressed together, pressure pushed them together, and they became hard rock. You can see the shells in the limestone rock if you look closely, so that'd be like a fossil print. Here is clay. Sedimentary rocks are softer than the other two kinds of rocks. Some are so soft that you can break them with your bare hands. Clay and chalk are too easy to break sedimentary rock. So that's why they erode very easily also and get weathered. So those are the first two, and here's metamorphic. Metamorphic rocks were once igneous and or sedimentary rock, but here's why they're not. Heat, intense heat, and lots of pressure change them into something different. Most metamorphic rock form in places where mountains are being made. Mountains are created when parts of the Earth's crust bump into one another. The bumping causes lots of heat and pressure. This heat and pressure changes the structure, crystals, of the rock. Limestone, which is sedimentary, becomes marble, which is metamorphic. A sedimentary rock called shale turns into slate or schist or gneiss, depending on the amount of pressure that it gets. Rocks can also be changed by just heat alone. This happens when a rock, the rock material, is pushed close to magma or to lava. Then that rock turns into something new if it gets hot enough. And then here you can see metamorphic rock that form under low temperature and low pressures have small grains, so small little pieces. The rocks that form in high pressures and high temperature have larger grains, larger crystals you can see. So, keys to the past is the last chapter here. Rocks last, chapter 3. Rocks last a long time, though they are non-renewable. Many of the rocks we see on the planet's surface are many years old. One rocky area in Canada is thought to be many, many years old. Old rocks hold clues to the Earth's past. So the rocks that we see, we can study them, learn about what was on Earth many years ago. Scientists who do this are called geologists. They study the rocks to learn about things that happened long, long ago. So rocks show us that Earth did not always look the way it does today. All of the planet's land masses were once jammed together. There's a theory of that called Pangea. That's what the picture might have looked like. They slowly drifted apart to form the modern day continents where they are today. Scientists know this, or think they know this, based on the fact that they have found the exact same rocks on different continents that are miles apart. Rocks also can prove that some dry areas were once oceans. The Midwest United States, for example, was covered with water. How do we know this, or why do they think this? That area contains rock that formed only in water in a sea. Even the world's tallest mountain was once underwater, which is Mount Everest has sea rocks near its peak. So this just proves that at one time, probably the earth was covered by water. Some rocks show signs of plants and animals that lived a long time ago. These type of rocks are called fossils. Here's some pictures. Most fossils form when dead plants or animals fall into the mud or some other gooey substance. The soft parts of their plants and animals rot away, but the harder parts don't rot. They stay in the mud, and then eventually that mud turns into sedimentary rock. The plant and animal remains are trapped inside the mud or soft material. Sedimentary rocks may also contain fossil footprints or leaf prints or other signs of ancient life. And those kind are called trace fossils. Fossils are not usually found in igneous or metamorphic rock. The heat that creates both of those kinds of rocks would ruin the fossil. Rock formations also tell us about the past. They teach us about the forces that shape Earth's surface. The Grand Canyon, which is the picture here, is one of our planet's most amazing rock formations. It is 217 miles long, 4 to 18 miles wide at different places, and it's more than a mile deep. The Grand Canyon, they think, was carved by the Colorado River, carved the Grand Canyon out of solid rock. It did this by carrying away small, tiny pieces of the rock. The bottom corner here is Devil's Tower in Montana. That is a volcanic plug. It also provides clues to the past. These rock formations were once magma inside of the volcano, the mountain. The magma come up, it cooled, but didn't come out, didn't get erupted out. Then, over many years, wind and rain and other forces weathered away and eroded away the land around the mountain that was the mountain, and now only this hardened magma is left. And then chapter 4, people and rocks. Rocks and minerals have many uses. The earliest people used powdered rocks and to make colorful paints. They used chipped flint and other hard minerals to make arrowheads. They also pounded rocks together to grind food. Today, people still use rocks and minerals for thousands of things. These substances are in our houses, our computers, our wrist watches, and our TVs. They're also in the roads, jewelry, fireplaces, and food. Life would not be the same without rocks. And here it just gives a few more details that I just read. Construction, electricity, electronics, jewelry industries. So they use it to build all kinds of things. We already talked about that. It's in all their electronic things. It's in jewelry. So based on the properties of the rocks and minerals, that's what we use them today. Rocks and minerals are so common in our everyday lives that many people decide to learn more about them. Or we have to teach our 6th graders about them. So this is just encouraging you to start your own fossil collection or rock collection. All right, so now go to AR, and the number for this book is that number right there. It's 10 questions. It'll get you half a point. Good luck.